morning, and welcome to Training Day. It's going to be a little different from that Denzel Washington movie. So this is the Catching Fire workshop. We spared you our pun of Catching Fire, the healthcare games. But if you, oh, there's your cable. If you have been on the dark side of the moon and not heard of FHIR, it is the Fast Healthcare Interoperability Resources standard that was formalized late last year in, I think, DIS 2, 2 or 3. You're going to hear all about these DIS 2 things. It's just a distribution. And it's a new standard for interoperability using these things called resources. And if you have any kind of a software background, you certainly know what objects are. You can think of resources as something like objects, but they're standardized for healthcare. And the current thinking is that this is really going to accelerate interoperability. We were at the ONC annual meeting in February, and every other speaker was talking about FHIR. A lot of talk about FHIR at HIMSS. We have a great lineup of speakers today, some of whom will be remote via WebEx. You can see the lineup for yourselves. Hope you can stay all day for this workshop, because toward the end, we're actually going to have one of the best presentations I've seen on FHIR yet, showing how the MITRE Corporation has combined FHIR and Restful APIs that they have implemented in a secure fashion. There have always been security concerns about REST, and Blue Button for the Veterans Affairs. It's an amazing presentation, so I hope you can stay to see that. I'd like to begin the program today by introducing Paul Groll, the Enterprise Architect for the Michigan Department of Technology Management and Budget. When I came to MiHIN in November 29th of 2011, 2 days later, the first person that I met who was involved in MiHIN and this whole statewide network of networks was Paul Groll. And we spent our first few minutes, first half an hour, trying to find a whiteboard in the offices we were leasing, and then we tried to find dry erase markers, and finally we drew out the MiHIN network and what was then the MDCH data hub and all the security zones. And so it's great to have Paul here 3.5 years later to talk about what happens next. So Paul is going to tee up with an overview of FHIR. He's got some great conceptual slides to share with you. And then we're going to kick it over to David Berner. Did I say that right?
Yeah, you did.
Wow, good. Lucky guess. The Senior Solution Consultant from Orion Health. He's going to give a more thorough introduction to FHIR. We'll take a break. Then we're going to hear about Argonaut. We have Dr. John Halamka, who's going to video in, and Mickey Tripathi to talk about the open APIs for FHIR in the Argonaut project. And it should be an exciting day, and we'll try to have time for Q&A after the topical speakers. With that, I'll ask Paul Groll to come up and give his opening remarks. Thank you.
Thank you, Jeff, and thanks to MiHIN for the opportunity to be with you today. So, happy Friday, everybody. Need a stretch, right? Get going. I'm really excited to be here because this is a very exciting technology for me. MiHIN doesn't even know this, we haven't talked about this, but back in the 90s, I was a CIO for the Library of Michigan. And libraries around the country were facing similar challenges on data interchange. There were about 1 million data formats, and none of them were compatible, and we were paying zillions of dollars to vendors to write one-off interfaces for point-to-point communication between library catalogs. And a standard came out that is very much like this for library catalog interchange. And it was very painful for quite a while because we were doing this over dial-up. So this is way more exciting now because we're talking 40 gig backbones and stuff like that. So I'm very excited about this technology and just want to give a foundation for the day here this morning. So one of the things, as Jeff said, there were a lot of talks on this at HIMSS, and for every talk there were probably about 100 dumb jokes about the FHIR topic. So I'm going to skip that. You don't have to suffer through that today. What this comes down to is communication, and that brings in automatically several problems that we have to look at between sender, receiver, message, and so forth. And when you look at the current state of communication in healthcare, it's more like this. I mean, things are everywhere. And moving that data around in a sensible way between everything becomes a real problem. We've got senders and receivers, we've got the channel, we've got the messages. So, you think at a conceptual level, this should be pretty simple. And it started out simple, but it's gotten way more complicated over the years. You've probably heard this before. I didn't even know it when I went to find this graphic. Jimmy Buffett did an album with this title, so probably violating some trademark already today. But this illustrates the point that there's a big difference between data, knowledge, and information. Probably the information garnered from this message by the recipient was not what the sender really had in mind, okay? As we heard in yesterday's closing talk, in healthcare, it is absolutely vital that the information is accurate. It's different than a lot of other fields where messaging has evolved and big data is coming into play, because we really can't afford to have errors. So we modify how we handle the data through developing languages, looking at the pragmatics of the meaning, structure, grammar, and this all boils down to using very tightly defined protocols for exchanging information. For those of you who've worked with HL7 v2 or others, you'll recognize that. This is kind of where we are. This is where the bulk of the country and the world is right now. And that's been a very serviceable model for evolution of the standard and evolution of the data exchange up to this point. But it's hitting some growth problems with age. A lot of implementations are unique at sites. Local rules can trump standards. Complexity has grown over time through the versions. Required versus optional data and fields have become problems because not all products or vendors agree, or implementations from site to site. So those all introduce problems. And for anybody who's dealt with it, all you have to say is Z segments, right? It becomes a customized, non-standard standard. So it was time for something different, and that different thing is FHIR, Fast Healthcare Interoperability Resources, a very much more object-oriented and if you will, modern way to encode the data for exchange. Resources are at the heart of FHIR's design. For example, you can have a group of resources that are referred to as attribution resources, which include things like patient, related person, and so forth. Each of these can become an independent object that can be shared on a small scale of data. And what I mean by that is, again, somebody yesterday mentioned the fact that as a doc looking at information about a patient, you get a 47-page PDF that's not really very useful. There's a big time crunch in trying to go through that information and glean what's needed. With FHIR, you can exchange information at the resource level. So we can parse out only the small bits of information that are relevant at the moment. Other groups include entities, so we can have objects like devices, location, so forth, diagnostics. All of these can be defined in the FHIR spec and exchanged atomically. Only the pieces that are needed need to be moved around. A typical object looks like this. I'm not going to go too much into this. You're going to see a lot more of this throughout the day. And there's a query. And slide's not going. There we go. This is an actual sample with data filled in, and there are two very important points here. that FHIR brings that are proving to be a great advantage. Number one, the part labeled text is a human readable piece that's inserted in there so that at a quick glance you can see data in text that a person can look at this record and make sense of it without having to try to parse the HL7 code as we saw a few slides ago. So that's a tremendous strength of FHIR. And the other thing I'll mention is at the beginning, you see there where we have extension. FHIR is designed to be able to use standard extensions from libraries that are codified and moderated by HL7.org. So if you have a need for a particular extension for data, you can write it and submit it to the library, and then it becomes available for anybody to use. So in this case, we've got something there based on around consent, and we're calling that extension at that URL, and we can use that in our code without having to write something custom just for our site. So it maintains the standardization across all users who are going to interchange this data. FHIR has a number of points that make it very attractive. It's fast and easy to implement. Many libraries and examples already exist. It's free, interoperable, out-of-the-box API. Again, I'll go back to the library example I talked about. We went from a state where it was very difficult to exchange data site to site because there was no conformance standard. We went to an out-of-the-box API with the library catalog systems where within 1 year there were more catalogs exchanging data than in the previous 25 years combined. So it really makes it very easy to set up and configure data exchanges because it's the same API at every site. Coexists with other versions, and I mentioned the human readability. Another great strength is if you've ever tried to implement a new software product or a new technology that is at all technical, you know it's difficult to find people to do the work. The cool thing about FHIR is that it's based on all these standards that already exist, and there are already literally millions of people who know these technologies, JSON, XML, and so forth. So as Jeff mentioned, it supports REST, and we'll hear more about that throughout the day. Uses messages or documents, and again, the extensibility I mentioned before. The current status is it's out there as a draft standard for trial use, DSTU they call it. Version 1 came out in 2014. Version 2 is due soon. I think I heard summer 2015 at HIMSS. And if you want to dive into it head first, that's the URL you're going to want. And with that, I'll turn it over to our next speaker.